All right, so as I was saying, guys, so the universal set would be the rectangle. And I was asking you how many subsets within this universal set. Now, if you are counting the improper ones, then we would actually have four. We would actually have four subsets. Can anybody? So if we are thinking about proper subsets though, we'd only have two. So what are the proper subsets that can be formed from this diagram, students? Ms. Cox, can you identify the two subsets from this diagram that I'm mentioning, that I'm actually talking about?
Sir, what do you say?
How many subsets, how many proper subsets in this diagram?
Sir, one.
Okay. Anybody else have any other opinion? Mr. Campbell? How many other subsets?
I'm not sure. I think that's the one.
Not sure. Ms. Clark, how many other subsets do you agree with Ms. Cox?
Sir, no one are confusing.
That one is confusing. Ms. Cummins?
So A and the other symbols somewhere there.
Where is it? Go again, Miss. Who was that talking again? Miss Cummins.
Coming, sir. A and this other symbol something.
The other symbol. You're talking about
Yes,
here.
yes, sir.
Oh, actually, this is a symbol that represents the universal set. So this one is not telling us about any subset. It's telling you about the rectangle. So that would be a subset. Mr. Arjena.
Not sure, sir.
All right. Miss McIntosh, you have always been paying attention.
Sir, I think it's two.
Yes, what are they?
Sir, A and in the rectangle.
Mm-hmm. A and in the rectangle. So we are saying that A and in. Can you specify or can you clarify? Okay. Did you make that mark just now?
Yes.
So you're saying where you mark, that's a subset too as well?
Yes, sir.
Okay.
And this part.
So anybody else agree with Miss McIntosh?
Can't you repeat, sir?
And what is
it was breaking up.
sir?
All right. So who was just saying that? Who is saying, Mr. Shamar, you weren't hearing me?
Yes, sir. It was breaking up a bit.
Right. Miss McIntosh was just saying that the subsets of this set would be the circle A, and she marked out here to say that that would also be a subset. So I'm asking you, are you in agreement with Ms. McIntosh? Yes or no?
Yes, sir.
Okay. Anybody else in agreement with Ms. McIntosh? Sir Giovanni, anybody else? Ms. Raysom, I'm not hearing you. Are you in agreement with Ms. McIntosh? Or do you have an answer for yourself?
Yes, sir, I am. If you're referring to the improper subset, sir, because those are the only set that I'm seeing there too.
But
The two, the null set and the universal set.
but is this a null set though?
What you're referring to, sir? The universal?
Where the mark?
Yes, sir, it is a null set too. So I guess it would be one. It's
Alright.
one set then, sir.
All right, so if we are referring to it in terms of we putting in members, it would be a null set because you wouldn't have any labeling of how many members we have there. But if you are referring it in terms of a diagram, then outside the set A, we would have members outside A too as well. So we have members inside A and members outside A. So when the members inside, when we have the member inside A, that would be all the members that are in the circle in that shaded region. But outside A, what would we call the set outside A? Outside
Universal set, sir.
circle, it's not a circle, but members can be out there. So in other words, let's say A is a house. Then this is a set where members live in this house. But let's say outside there is not a house. Then outside members can live outside on the street and they're still in the universal set. You get what I'm saying, Ms. Rayson?
Sir, can you repeat?
I was just saying that if you consider the circle a house, then every member that live in the circle will live in a house. But if outside you have members who don't have house, then you can also have people living outside without living in a house. You agree?
Yes, sir.
Right. So what would we call the set outside the set A? It's not a circle because it is not defined in a circular way, but we have to know that even though outside is not defined in a circular way, it is also a subset of the universal set. And we call outside the set A, we call it A complement. So those would be the members who are not in the set A. Is that clear to you all, students? Yeah, Mrs. You are understanding what I'm saying.
Sir, so there are three subsets.
Which other subset you're referring to now, Miss?
Sir, A and inside the square and outside. So that would be three subsets.
No, so you would only have inside the circle A and outside the circle A. Outside the circle A would be the square section here. There's all that is shaded in the red lines that I drew. Everything outside in the universal set. The same area that you would have marked, Ms. McIntosh, is the same area that I'm referring to as A complement.
Okay, sir.
All right?
Yes, sir.
Is that clear to everyone? All right, is that?
Yes, sir.
Okay, all right. So here now, the complement of set A, notice the region which is shaded now. Now, the region that is shaded, it would be outside the circle. So outside the circle is a subset too. It's not a circle. It's just a set outside of the set A. And we call that A complement or A prime. So A complement is everything outside the circle A and is referred to as the complement or prime of A. The complement of a set is the subset of the universal set that does not belong in A. This is represented by the shaded region in the diagram above. Now, these two sets are called disjoint sets. Now, can anybody give me an idea why we call these disjoints?
Sir, because
Because they're not intersecting each other.
they intersect each other.
All right, exactly so. So there's no connection with the two sets A and B. They are not overlapping, meaning that they don't have any common member. There's no member that is in A, which is also in B. So because of that, they are independent and separate apart. So we say they are disjoint or they are not joined. All right? Okay. So here now, if we are to talk about the intersection of two disjoint sets, it would be what? Null, because there is no overlapping. Intersection is where there is a common overlapping. Go ahead, Ms. Clark.
Question, sir. If we're to look at the universal set there, sir, and how much subset would we say is in that one, sir?
Okay. So I like your question. So here now you have the set A, you have the set B, but you have A complement as well as you have B complement. But it just so happened that A complement and B complement are overlapping. You follow what I'm saying, miss? So there are two, the two complements are united together. So in other words, there would actually be 4 subsets. Does that answer your question, Ms. Clark?
Yes, sir.
Okay. But that's a good question. That means you're thinking. All right, moving along. So we say that two sets that are disjoint, the set A and B, they don't have anything in common, so there's no region where they are connected. All right, so the intersection of A and B now, where two sets are overlapping, the region that they overlap would be a region where you have members common to both sets. So if there's a member in this region, so let's say there's a member X right here, then X would also be in B and X would also be in A. Right, so this region is common. So any member in this region would be in both sets. So we are saying that A intersect B mean the region where you're in A and as well you're in B. So this region is A and B, right? Anybody in here is in A and B, and that's what the A intersect means. A intersect B means. All right. But what if you have some member Y in this region? So if you have Y in this region and you have Z in this region, would Z and Y be connected?
No, sir, because they are in one is in A and one is in B. It is not in the middle.
Now, if we are to refer to this region, which is not in the part of the overlapping, sometimes CSEC will call this region, what they would call this region, let me see if anybody is thinking. This region that is not in the overlapping, what they would call that region, as well as
Disjoint region.
not disjoint region, and as well as in this one, what would they call this region? So this region here, you notice that any member in this region, where would they belong? Where would they be, which set or what subset would they be in? But this is also a subset, you know. How would you describe this subset? If you had to describe this subset, what would this region, what would you call it?
Subset of A, sir. So Y would be a subset of A
All right.
and Z a subset of B.
All right. So to say subset of A would be a little tricky because this region here is also a subset of A. So how would you make a distinction with this subset of A and this subset of A? You get what I'm saying, Ms. Wilson?
Yes, sir.
So we couldn't call it just subset of A because it would be in conflicting with this region. What else could we call it?
A prime.
It wouldn't be A prime because A prime means outside the circle of A. Would that
Oh.
be the circle of A? All right. Oh, Mr. Shamar, you were saying something.
I was going to ask a question about what it would look like another Y outside the circle, but I guess that does answer my question.
Okay.
Mhm.
So anybody would support, so what would you call that region then? If you were to describe it as a set, or what would you call it? All right, so they actually have a description for it. And one, you can use the set symbols to describe it. And two, you can use words to describe it. Now, so in general, when CSEC is describing these regions in words, they would call it A only. So the only now would qualifies only that part of A that has member to it. So this is only A only. Now here, we wouldn't be able to say here is A only because this is not just A only, it is also A and B. You follow? But this section, whoever over here, they are only in A. They are not in B. So we call this A only. And likewise over here, this is also called B only. Now, so A, the set A is different from A only. Ms. Cox, do you have something to say?
No, sir, mistake.
I noticed that you're drawing up on my diagram.
Yeah, mistake.
All right, is that clear to everybody, students? Is that clear? Let me see the answer and what A only means. It is in that region of A where only elements of only members that are in A. And B only is that region of B that only members are in B. All right, moving along. So the shaded region in this middle is A intersect B. All right, looking at this set now, what you notice here, we shade both A and B together. Anybody know? All right, so it's a given, it's already there. So this region is called what? A union B. Now, when we talk about the union of a set, we can consider that what we are doing, Miss Taylor, are you on yet? Are you back on now? Miss Taylor is sending us a message that she keeps jumping on and off, so I guess her internet is not so stable. So I was just asking now, if we understand what it means when we say the union of A and B. So when you're talking about union of sets, all it is saying is that you're uniting everybody in the sets. So if you have two classes at school, so you have a 9th grade, if you say 9-1 and then you have 9-2, then if you bring the two classes together as one group, then that would be a union of 9-1 and 9-2 because they're dealing with everybody in 9-1 plus everybody in 9-2 together. So that means you're having a party and invite everybody to the one party, so you're uniting everybody. So a union of a set is really combining all the members in both sets. Whether or not you have, if it's just two sets, you're combining all the members in the two sets. If it's more than two, because you can have union of 3 sets and so on. So a union is just a combination of all the members in all the sets. Is that clear to everybody? Let me see your hand.
Yes, sir.
Okay.
Sir, I have a question.
Go ahead with the question.
Is that is there like an activity in the structured exercise on set?
No. And there's a reason for that. Over the years, CSEC would have had structured questions on set. But in recent time, the set questions are limited to the multiple choice section. So even though we are doing this topic, you probably won't see it in the structured area of the structured paper, but you will get questions on the multiple choice paper that relating to sets. Is that clear? Does that answer your question, Mr. Campbell?
Yes, sir. Yes, sir.
Okay. All right. All right, so moving along. So here now we have, remember, subsets. So this is how we would have represented subsets. And here now, this is just a little extra because as it is now, CSEC won't give you any 3 overlapping sets to deal with, but I just throw this in the mix. You know, lucky you are now these days, because in the earlier times of CSEC, they usually have these questions on it, both in the structured paper as well as multiple choice. So you could look and see 3 overlapping sets in CSEC in those days. But you know, lucky for you, they don't no longer put those on the curriculum or the syllabus. So I guess it is kind of making your life a little easier. It doesn't mean that you shouldn't learn about it though, because it still remains a relevant part in mathematics. And if you learn this Venn diagram thing, it will help you in probability as well, because the same concepts that are shared in sets are also shared when we're looking at probability. All right, guys. So now, if we are to look at this diagram, that shaded region that you see there would be the region where all 3 sets have a common element. And so this region is the intersection of all the 3 sets. And so in the symbol form, we would write A intersect B intersect C, which is the region where all the 3 sets overlap and have common members. All right. Moving along. Now, if we have this diagram, then this would be a union of all 3 sets. So clearly, you're going to combine everybody together. Now, if you have a set looking like this, then oftentimes you may get a multiple choice and it says describe the shaded region. And for some reason, because this set A is overlapping on it, most people don't realize that it is only the circle B that is shaded. So this shaded region is just a set B. But because this A overlapping on it, it confuses students. So if you see a diagram like this and they ask, what is the shaded region? The region is just B because it's just a circle B that is shaded. All right. Now, if you have a region like this, we know what this is already. It's an intersection of A and B. If you have something looking like this, though, it means that you are shading outside of the union of A and B. And remember, if you have a circle, outside the circle would be the prime or the complement of the circle. But this is outside the union of two sets, outside A and outside B. And so if you use the two sets together, the white region would be A union B, but the shaded region would be outside. So we would say A union B complement because we are looking at outside of the union of A and B. Is that clear, guys?
Yes, sir.
Now,
Yes, sir.
the same representation can be written as A prime intersect B prime, which really means the same thing, meaning that outside of A, everything outside of A and everything outside of B. If you look at the circle A, everything outside of A would be everything outside of the circle A. Outside of B, everything outside the circle B. So all that would have remained is just the purple area when you look outside of A and when you look outside of B. So you could write the intersection of outside of A. So A prime. So that would be in outside of A, and B prime would also be outside of A and outside of B. So when you have a region where you have common members, so you have members outside of A and members outside of B, that is an intersection. All right. Any questions?
So, sorry, you're saying that so if we should get a question like that, we could either put A union B or complement or A
complement, right?
Or A complement intersect B complement, and we would get it correct?
Yes, the two symbols here are actually saying the same thing.
Okay. So
whether you have A union B complement or A complement intersect B complement, it means the both of them are the same.
Okay, sir.
All right. You may have this depiction, and this depiction now, the only region which is not shaded is the white section, and that section is A intersect B. So the region that is shaded is outside, and outside of a set, we call that the complement of the set. So if you have outside of A and B, then we could just write A intersect B complement, because the complement gives you outside. So A intersect B complement. Another way you could write it is A union B, A complement union B complement, which would be the same thing as A intersect B complement, just as before, where we have two symbols to represent the complement of the union. Now you have two symbols representing the complement of the intersection. All right, hope you guys are following. Here now, all right, so we would have looked at union already. Now looking at this set now, if we are to describe the shaded region, you could call this region A only because it is a region only where members are in A. Or if we're using the set symbol, we would call it A intersect A complement. Sorry, B complement. A intersect B complement. Now, I want you to be able to see why it is described as this. Can anybody tell me why they would use that symbol to describe that shaded region in purple? Can anybody try and explain why it would be shade, why would it be those symbols?
The shaded part though going to be any at all.
Right, so if the shaded part is not in B, then it would be a complement of B. But remember that B complement is everything outside of B. That means out here, so it's also B complement, you know. But now when we say A complement intersect B, it means that this region is both in the complement of B and it is a part of A. So this is an intersection. So this is a complement of B overlapping with A only region. You see that? So this part that is in A only, it is also a part of B complement. So we wouldn't call this B complement. It would be incorrect to call this B complement, because B complement is everything outside of B. So because this is a part of B complement and it is also in A, then it is an intersection, because an intersection is where you have two sets overlapping that have common elements, right? So we say that A, the region of A, which is common with the complement of B. So it's A intersect B complement. Now let me just check and see whether or not you get the idea clearly. Now ignore the fact that this side is shaded. Ignore the fact that this side is shaded. How would we describe this using the symbols? I want to see if you really get what I'm saying. Anybody, can you describe that region for me using?
Sir, can you repeat, please?
So this region that I just shaded, pretend that the purple part wasn't shaded, right? We are focusing on the part that I draw the lines now. How would you?
Oh, so that would be called B only.
No, apart from just the worded part, B only. How would you?
Is it the
Intersect A complement.
A complement? Yeah.
Exactly. So it's B intersect A complement, because this part is outside of A. So it would be a part of A complement, but it is in B. So it is both a part of A complement and a part of B. So it's an intersection of A complement with B. So you can say B intersect A complement. Or you could even say A complement intersect B, and there wouldn't be anything wrong with that. They're just flipping it around, because the ordering of set symbols are commutative. You can write them, the order doesn't matter. All right, guys. All right, moving along. So this part, which is what we would have looked at, would be B intersect A complement, or simply just B only. All right, now if we are to look at this now in the context of tree sets, let me see how well you could describe that. although it is already written there. But can you see why though? Can you see why? All right.
Yes, sir.
All right. I will have to stop the slide here. Recall that I said that I wanted to just share the groups of the SBA, and I was supposed to do it before the end of the class, which is now the end of the class, but I'm just going to take the time out now to just share the listing of members in the SBA groups. And so once I see the list and you know the members you're working with, I'm going to put those members in. So let me stop sharing this. And let me share the list. And this is our SBA listing. So group 1, the members would be Ms. Waysome, Stravia, Ms. Chavelle, Ms. Ashanti Ojeno. You would be in group 1. Group 2, I have Ms. Amanda Scott, Javon Arthurs, and Shamar Campbell. Now, I know some of you who are not actually, you are not going to be doing an SBA per se for the exam, but are still going to put in an SBA group so that you can work with the others on the SBA. All right. All right. So group 3, we have Ms. Shea, Ms. Taylor, Ms. Clark, Ms. Williams, Ms. McIntosh. You are in that group. And group 4, Malika, Ms. Cox, Aisha, and Giovanni, and Ms. Cold Spring. You are in that group. Group 5, Mr. Pearsley, Ms. Andrews, Ms. Nelson, Ms. Bellani, Ms. Watson. I'm not sure if Ms. Watson, no, I don't think she's joined. She's a new member, but she's not here today. Hopefully she'll be here next class. Group 6, we have Ms. Cindy Reed, Ms. Cabrera Finch, Ms.